So we got 7.3 log functions. You got your learning goals. We've got the definition of logs. Logs are opposites of exponents, just like the opposite of multiplication is division. A log is a way to undo an exponent. Okay? They're inverses of exponents. Reading a log, y equals b to the x, can be written as log b of y equals x. We read that as log base b of y equals x. Remember, all year, or all lesson, this whole chapter, I've been talking about b being our base. We read that as a base because when we start talking about log form, we actually say log base whatever b is. Okay. All right, so we've talked about this, reading a log. Just make sure that everyone understands that when we have y equals b to the power of x, that can be written as log base b. So this is our base. So we move that over. Okay, log base b of this. So this piece moves over to there, and we call it log base b of y, and then the x becomes big. Okay, that's kind of the typical movement. Now, that wasn't a big mathematical explanation, but log base b, okay, the base moves over, becomes log base b of that equals that. Okay? All right, so why do we need logs? Well, if you're going through and trying to solve for x, go ahead and you can just tell your neighbors here. What is x here?
10.
Uh-oh. 10 to what power is 1,000?
2.
Oh.
2. 3. No, 3. That's 3. 3. That's 3.
10 to what power is 100?
2.
10 to what power is 10?
1.
10 to what power is 1?
0.
Okay, we're following that pattern. 10 to what power is 1/10?
Negative 1.
Here?
Negative 2.
And here?
Negative 3.
Okay. What's the answer to that one? 10 to what power is 29? So the process we'd have to normally go through is just a guess and check process. I mean, we could say, well, 10 to the first is 10. 10 to the second is 100. It's in between. X is in between what two numbers? It's in between 1 and 2. Probably closer to 1. Yeah. Yeah. So what you would end up doing to get x by itself and make it big is we take that base and we move it over. So we now say log base 10 of 29 equals x. And in fact, if you find log on your calculator, the log button, if you type in log of 29, that 10's not going to appear there. If you just do log 29, that will give you the answer. What is the log of 29? 1.46. Okay, so it's approximately, right? That's rounded. So about 1.46 is what x is. So if you took 10 to the 1.46 power, you should get about 29 because you're rounding it off. It's going to probably be a little less than that. That's how logs work. Any questions there? Okay. Well, so what we need to understand is there are different bases in logs. So one thing that we talk about is what's called the common log. Okay, now you can reference 320 if you want to at a later time of your text. But the common log is a log base 10. So the word common log refers to a base 10 log. All right, now it's important because your bases change. We don't raise 10 to a power every time. I mean, if we have say y equals 2 to the x power, that's a base 2. So when we take and write that in log form, that would be log base 2 of y equals x. That is not a base 10. Anytime this thing that's being raised to the power is 10, that's a common log. That's called a base 10 log. Your calculator only works in base 10. At least the log button does. Okay, now some of your calculators work in other bases. Question?
If you click under math,
Okay. Right now, I don't want to do that, though, okay? Right now, I want you to learn this process, okay? So eventually, you'll be able to use the calculator to do other bases. I don't want to do that right now. If you push the log button on your calculator, just the log, that is a base 10 setting, okay? Most calculators are, when you hit that log button, you are dealing in base 10. You are dealing with the common log. Why? Because our numbering system is a base 10 system. Okay? Now there is a way to do logs using your calculator and other bases. We'll talk about that. However, on your tests, you won't be using a graphing calculator. So, that's okay. We'll get to that later. Special cases. Log base A of A is equal to 1. Anytime your base and the thing you're taking, that your y value are the same, it's 1. Now go this way. This way. This way. No, this way. Through the door. Use the door. Log base A of A is 1. Okay? Anytime you say log base A of 1, anytime you're taking your base is equal to 1, log base A of 1, that's equal to 0. Those are special cases. All right, why is that? Well, if we think about it, if we write them in exponential form, the exponential form, if I brought this back over to here, what would that be? Yeah, this would in exponential form, this is our base is A raised to that power equals A. Well, A to the first power is always A. That's why this equals that. And if I wrote this in exponential form, really, if I brought this piece back over and thought of it that way, 1 equals A to the 0 power. So if you're confused in log form, you're like, why is that? Try to write it back in exponential. It usually explains it. And if I wrote this in log form, it would look like this, right? Okay, so you're just undoing that. Those are our special cases. So anytime you see those two things the same, it's 1. That and 1, it's 0. Okay? Common bases is where we're going to start in our next lesson. Okay, we'll talk about some common bases. Okay? All right, so that's where we'll start. We'll pick up tomorrow. All right?